Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss one very important question related to Kafka, and that is how many partitions should I create while configuring a new Kafka topic in our Kafka cluster. So believe me, for this particular question there is no direct answer. The complete answer depends on the business use case for which you are creating the Kafka topic. Okay, but still I will try to discuss with some examples which will make some understanding on deciding the number of partitions for a particular topic. Okay, so let's consider case 1. Suppose here we are having our Kafka cluster. Here we are having our consumer. Here different producers are producing messages and publishing in Kafka topic. Okay. Now suppose in this particular business use case, incoming message throughput or speed is 1000 messages per second, right? And one single consumer can consume the messages and process at a speed 100 messages per second. Okay, right? So here from this particular scenario itself, you can understand that we might need to run 10 consumers parallelly, because 1000 is our incoming message speed per second and one consumer is processing at a speed of 100 messages per second. So if we just do simple calculation, we are getting value 10. So you can think of that we will be launching a consumer group in this right hand side. Okay. And within that particular group, like this one consumer, we will be having here, this is consumer 1 and this is here consumer 10. Like that, 10 consumers are consuming the messages, each with speed 100 messages per second. That way, our consumer system will not be lagging. Okay. Now to run 10 consumers parallelly, what we need to do? We need to have 10 partitions within our Kafka topic. Okay. That way we can achieve max parallelism, right? So here you can see that suppose this is our Kafka topic 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These small boxes are partitioned. So what can happen in the best optimal situation? That out of 10 consumers within the consumer group, each consumer will be consuming the messages from one single partition. Because in Kafka, from one single partition, multiple consumers cannot consume the messages, right? But one single consumer can consume the message from different partitions, multiple partitions. That is perfectly possible scenario. Now to increase the parallelism and processing speed to its max value, what we can do, that one single consumer, we can assign it for processing one single partition. Okay. That way the complete throughput usage we can do in our consumer side, right? So that way we can easily understand in this particular context that we can simply launch 10 consumers within a consumer group, and for max parallel processing, we can have 10 partition within the Kafka topic. Okay. That way, here, this can give us some idea that what should be number of partitions for our topic. Obviously, for buffer purpose or for safe side, we can have 2 more partition. So we can launch the Kafka topic with 12 partition. So that way, if in future, suppose this particular 1000 requests per second, this business requirement or the volume of message or the incoming message traffic, if that is increasing, then we can launch 1 or 2 more consumer within the consumer group. So for that particular buffer purpose, we can have 2 more partitions. Okay. So that way we can decide that 12 can be a optimal count for this particular business requirement. I hope you simply got it. Now let's consider our case 2, which is little complex than case 1. Okay. And here in this case also, here suppose we are having our Kafka cluster, this one. Okay. And then here we are having our multiple producers who are producing the messages in a rapid speed. And here we are having our consumer. Okay. Now, in this particular case, suppose the consumer message processing speed is very high. Suppose it is handling 10 million messages per second. Okay. And as per the business requirement, the incoming message speed, for example, let's consider 30,000 message per second. Okay. So, incoming message throughput is much lower than our consumer message processing throughput. Okay. Right. So, here you can easily understand that one single consumer is more than sufficient to fulfill the business need, and if we are having one single consumer, then also the consumer will not be lagging. As simple as that, right? So what we can think of, that we can launch the topic with one single partition, right? The small box is denoting partition, the medium box is denoting the topic, and the outer bigger box is denoting the Kafka cluster. Okay. So this might appear a perfect architecture because the consumer throughput is much higher compared to our incoming message throughput. So we can create only one topic with only one partition. But there is a problem in this particular case. And what is that? So here, if you are creating a topic with only one partition, so obviously the partition will be sitting in a broker, and that is the only leader broker for this particular Kafka topic, right? You might have multiple replication for this particular partition, so that follower partitions will be sitting in other brokers, but this particular partition, the leader partition, will be sitting in a leader broker. For sure, this is clear, right? Now, all the different producers who are producing messages in this particular speed, 30,000 messages per second, all these producers will have the connection with a single leader broker where our leader partition is sitting, and they will ingest the data in the rapid speed. Okay. Now, one single broker handling this much load is not a good architecture. As per the architecture, at least the broker should have reasonable volume to handle. So what we can do, although in this case one single partition is sufficient, we should have at least 2 or 3 partitions for our Kafka topic. So that way different brokers will have different leader partition, and this 30,000 requests per second or 30,000 messages per second or 30,000 events per second will be distributed among multiple leader brokers. That way one single broker will get less burden. Okay. So this is another important point apart from consumer message processing speed, that one single broker should not get high burden in message consumption. Okay. So this also you need to take care of while calculating number of partitions for a Kafka topic. And let's consider another case here. Suppose here we are having our Kafka topic. Okay. Here we are having our Kafka consumer. Here multiple producers are producing messages to this topic. Okay. So here I am just writing in small letter that producer, and here this is our consumer. Okay, right? Consumer is consuming the messages. Now suppose in this particular business use case, the rate in which messages are coming, that is incoming message throughput, if you consider, suppose that is 1 lakh requests per second. Okay, and one single consumer message processing speed is 100 messages per second, right? So in that case, if you consider our case 1 like that way, if you compute, so 1 lakh divided by one single consumer message processing speed, that is 100. So these 2 zeros will be cancelled out. So it is coming 1000. So to get max parallel processing, we can have 1000 consumers launched within a same consumer group, and to achieve that, we should have 1000 partitions for our topic. So that way individual consumer will be consuming messages from one single partition, and that way optimized parallel processing we can achieve. Okay, it might appear as simple as that, but this is also not a correct architecture. The 1000 partitions is unrealistic. Why? What problem we might face if we configure 1000 partitions for our topic? One simple problem which I can tell you, that is always whenever we are having partition and replicas, basically Kafka need to handle the leader broker where the leader partition will be sitting, and Kafka in the backend need to manage in replicating that data in the follower partitions which are available in follower brokers and all those, right? So think like this is when you are having 1000 partitions in the backend, choosing the leader broker, follower broker, copying the data from leader to followers is a very complex and big operation. Our Kafka brokers will be heavily involved. Huge memory usage and CPU usage will be having for these 1000 partitions, right? So this particular heavy burden we cannot simply put in our Kafka cluster. Obviously, you can start with some realistic partition count based on this kind of calculation, and then in future, if you observe that your consumer is lagging, what you can do? You can launch new partition within the same topic and then scale up the consumer group by launching one more consumer, so that way that consumer will start consuming the messages from the newly created partition, and that way consumer lag can be reduced. Okay, so just think like this way. Obviously, whatever case 1, case 2, case 3 I discussed, these are important factors while deciding the number of partition. So we will start with a realistic value, and if we are checking that consumer lag is continuously increasing, we will increase the number of partitions for that particular topic, and then we will launch a new consumer within that same consumer group to reduce the consumer lag. Okay, so now we need to understand, suppose we have already created a topic, for example, with one partition, and in future you are seeing that one single partition is not fulfilling the business requirement and the consumer lag is increasing. So suppose you want to change the partition number from 1 to 2. Okay, so that way what you can do in the consumer group, you can launch one more consumer. That consumer will start consuming the messages from newly created partition. How to do that? That we need to understand. That is how to increase the number of partition for an existing topic. Let us try to understand that with a very simple lab experiment. Okay, so here I will go to my notepad and first I will launch Zookeeper in the PyCharm terminal. So here our Zookeeper is started in port 2181, and here I will start my Kafka server also. So here Kafka server will start in port 9092, and now here we are creating a topic with one single partition. The topic name is sensor data consumer. So here the topic got created. Now we will start publishing the data and start consuming it. So it is very simple producer code which I already discussed, that we are importing all the necessary modules. Here we are having our custom partitioner. What it is doing, the key part, it is dividing by total number of partition, and then whatever remainder we are getting, based on that it is moving the data to that particular partition. Suppose the key after dividing by total number of partition we are getting the remainder as 2, then it will move to partition 2. If we are getting remainder as 1, it will move to partition 1. If we are getting remainder 0, it will move the data to partition 0, like that, as simple as that. Okay, and here we are starting our producer. We are providing our bootstrap server which is running in localhost 9092. Value serializer we are keeping simple JSON serializer. Topic name we have configured, and with each 10-second interval we are publishing the data in fire and forget manner. And here we are having our consumer. So here we have written our rebalance code, that is whenever rebalancing will happen, it will print that rebalancing happened. And then here we are defining our consumer within this particular consumer group ID. Okay, and the auto offset reset earliest. So here auto offset reset can be earliest or latest. What is their difference already I discussed, you can check the description link. And here we are subscribing to that particular topic, we are consuming the message. The same code I have written in another Python file. So this way two consumers we have created within the same consumer group. See here group ID and this consumer's group ID are same, right? So here what I will do first, I will start this particular consumer. Okay. So here see, first whenever we are launching consumer, first partitions will be revoked. So for this particular consumer there was no partition earlier assigned, right? First time we are launching. So here you can see the partition, only one partition is there, partition 0, that is assigned to this consumer, right? And here we can launch our second consumer now. So a new consumer is joining the consumer group, so internally rebalancing will happen. So first all the partitions will be revoked, and if required the partition will be assigned to the newly joined consumer within the consumer group. So here this consumer has got no partition assigned. So our first consumer whatever we have launched, that only is consuming the message from only one partition as of now, whatever we are having in our topic. And you can check the log directory also. If you go to server logs, here you can easily see that sensor data consumer, this topic as of now is having only one folder. That means it is having only one partition, and that partition is partition 0. Okay, right? Now here what I will do, I will start producing the messages. Basically I will start the main file. Okay, so here see, it is listing what are the partition number we are having. So only one partition we are having, so it is showing partition 0 only as of now for our topic, and it published the message. Now second message it has also published. So here our second consumer is sitting ideal because here no partition is assigned. All the messages whatever got published will be going to our first consumer because it has subscribed to the partition 0 for our topic. Okay, offset 0, offset 1, offset 2, all these messages it is consuming in order. Okay, right? Now here what we will do, suppose the business team think that the speed is not that much high, so we need to scale up the consumer side. Now we cannot scale up the consumer side as per the current situation, because within our topic we are having only one partition, right? So at max within the consumer group we can have only one consumer, and that is consuming. Other consumer is sitting idle, because from a single partition two different consumers cannot consume the message. So to scale up the consumer side, we need to add one more partition in the topic. So that way two consumer can parallelly consume the messages, and the speed in the consumer side can improve, and that way consumer lag can decrease. Okay. So to increase the number of partition in an already existing Kafka topic, you have to execute this particular code. That is, bootstrap-server is Kafka broker URL, and then alter topic. The topic name you have to provide, and the partition count. So earlier partition was 1. Now we are increasing that to 2. Okay. So here I will go to terminal. I will paste this. I will hit an enter. As soon as this will be executed, you will observe that instead of one single folder, now one more folder got created. So this is indicating partition 0. This is indicating partition 1. Okay. But immediately this particular consumer rebalancing will not happen, or this particular consumer will not start consuming the message. Okay. Because this particular topic metadata refresh happens with certain time interval. So let's wait for a couple of seconds, and then we will observe that in the producer side, as of now, if you observe, it is listing that for this particular topic it is having only one partition, and that is partition 0. Although the Kafka topic it is having two partitions, but it is still showing partition 0. That means topic metadata is not refreshed yet. So just wait for a couple of seconds, and you will observe that soon it will start displaying that it is having two partitions. One is partition 0, one is partition 1. And that way, the consumer 2, which is sitting idle, that will also start consuming some messages. Internally rebalancing will happen as soon as the topic metadata get refreshed. Okay. So we need to wait a little bit. Let's wait for that time. So see, now the topic metadata got refreshed, and now when producer is printing the total number of existing partition for the topic, it started showing 0, 1. Earlier till now it was showing only 0. So that means now the consumer 1 internally will consume only from one partition. So here you can see it is consuming only from partition 0, and the consumer 2, which earlier was sitting idle, now it also started consuming. Internally rebalancing triggered, and it got assigned the partition 1, and see all the odd numbers it is consuming, 31, 33 like that, and the first consumer is consuming all the even numbers like 30, 32, 34 and so on. Okay, right? So this way, obviously you can start with a reasonable calculation, but if suppose in future your calculation is not working well, if suppose you need to increase the consumer side or you need to scale up the consumer, you can easily alter the number of partition for the topic, and then once the topic metadata gets synced with the producer, your consumer group can also scale up, and now two consumers or n number of consumers can parallelly consume the messages. Okay. So I hope you understood this. This is one of the very important question while having big data interviews, especially in Kafka profile, or even in real-time projects also this question might arise while designing the system. So I just thought to discuss this with real-time example. This is all for this video. I'll be providing the codes in the description box or in the comment section. Just play with it, then you will understand the concept in a much better way. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.